let us say that our f of x was of this particular form. Okay, we are plotting f of x against x. An example of this particular equation is, for example, if we have x square minus 4 equal to 0. Okay, so this is going to be an example of that. So actually this won't be. So let's just look at the case where x square equal to 0 rather than x square minus 4 equal to 0, and this particular guy is 0, and this curve is going to be essentially tangential to this particular axis. If we look at any point on this curve except for the origin, at all the other points on this particular curve, our basically our f of x is always going to be positive. Why just look at x square equal to 0? We could also look at, say, x minus 1 squared equal to 0. So in that particular case, the point 1 comma 0 is the true solution, is the true solution of this particular equation. But any point you take along this particular curve, our f of x is going to be greater than 0 for any point which is not equal to x equal to 1. Okay, so if we will try to use any of the bracketing methods, we will not get any admissible solution, because no matter which 2 points you take on this particular curve, our f of xl multiplied by f of xr is always going to be positive for this particular example. Okay, so no matter what method we are going to use, we will not be able to get starting initial guesses for a bracketing method. However, when we are looking at, for example, a secant method, the secant method does not have any problem in an example of this type. The reason why it does not have a problem is that it does not matter that f of xl and f of xr is going to be positive or not. In either cases, the secant method is going to work. There is one problem, however, for this kind of a curve for the secant method, is that if the line joining f of xl and f of xr happens to be parallel, if it is parallel to the x axis, then there is no point at which this particular line is going to intersect the x axis, and our secant method is not going to work. In other words, what do we really mean by the line being parallel to x axis? It's nothing but fi minus 1 equal to 0. This is when secant or the reguli falsi method fails. Okay. However, the secant method will not fail if we have even a slight difference between xi and xi plus 1. So if we have a situation of this type, we can always connect this point. We will essentially get this particular point as the next point, and then we will be able to connect this, we will get this as the next next point, and so on and so forth, and then we can continue and we will end up reaching the solution eventually. Okay. So this is what we'll end up getting, and using a secant method. The secant method will still be able to employ to a problem of this sort. However, the reguli falsi method we will not be in a position to employ in an example like this. Now let us look at another example. F of x equal to 1 divided by x. in this particular case the curve looks like this. Okay, it's a hyperbolic type of a curve, and essentially when x is very close to 0 on the positive side we will reach. So for example, if x is 0.001 we reach plus infinity. When x is going to be equal to 0.00 minus 0.001 we will reach minus 1000, and as we go closer and closer to the y axis we will go towards infinity. Now this particular example does not have any solution because this curve does not intersect the x axis except essentially at infinity. Okay. However, if we are going to use a bracketing method, especially a bracketing method such as the bisection method, these two are going to be admissible solutions. This is going to be our xl because, and this one is going to be our xr. The reason is the product f of xl multiplied by f of xr is going to be negative, so these are going to be our admissible solutions. So eventually as we reduce this so the next point is perhaps going to be over here. This is going to be our new xr, then the next point will end up being over here. This is our new xl, this is going to be our new xl, and so on and so forth, and we will eventually reach the origin. As we approach the origin, what we will find is that f of xl tends to minus infinity, f of xr tends to plus infinity. So although the solution does not exist for this particular problem, we will be able to figure out that this particular curve has a discontinuity close to that at the particular point at 0, whereas such properties of the curves we will not be able to obtain using any of the open methods that we look at. This is kind of a cheating a little bit, because in this particular example we know a priori that the solution does not exist, and we are tricking our problem, and we are essentially making a trick to say that a bisection type of a method is able to figure out that the solution does not exist, whereas a method like say a secant method or the Newton-Raphson's methods or the other methods that we are going to consider here, those methods will not be able to figure out that the solution does not exist for this particular problem. Okay, so this is in general about bracketing and open methods, and specifically about the secant method.